Let's look at this. Okay, you might think this is just a ridiculous jump in difficulty. We were just dealing with all these quadratics, and now suddenly we have a quartic, or we might not even remember what quartic means. It means degree 4. Just polynomial with a very high number that's small in the exponent, x times x times x times x. What are we doing? Looks a little scary. I want to remind you guys something. Of all of the different formulas that we had for products, this might be the most essential, the one that shows up the most. Meaning, if you have to forget stuff, don't forget this one. What does that have to do with this? This is an x to the 4th. Well, we can use this whenever we have a difference of squares. Is this a difference of squares? Well, x to the 4th is x times x times x times x. That's x squared times x squared. So what would happen if I let a be x squared and b be 9? Well, I have x squared squared, which is x to the 4th, minus b squared. This is something of the form a squared minus b squared, which means I can use this formula. So what do I get? I get x squared plus 9, x squared minus 9 equals 0. Okay, I'll give myself some room over here. So now I want to solve this. Notice something. X squared is always positive and 9 is always positive, so there's no way we're going to be able to factor this any further. This is irreducible. But this is just another difference of squares. Obviously, x squared is a square. It's what we get when we square x. 9 is also a square. It's what we get when we square 3. So what do we get here? Well, I'm going to keep the irreducible, and I'm going to use my formula again. I get, if I use this formula, x plus 3, x minus 3. Okay, this product's going to be 0 when one of the pieces is 0. So, first of all, is this first piece ever 0? No, because whatever we get a positive plus a positive. Even if I put 0 in here, I get 0 plus a positive, it's still going to be a positive. So this is never 0. So this is going to be satisfied when x plus 3 equals 0 or x minus 3 equals 0. I'll go over that one more time. This is a product of things that's equal to 0. The only way this can be 0 is if one of these pieces is 0. This piece is never 0. No matter what I put in, if I put in a positive or a negative, I'm going to get a positive. If I put in 0, I'm going to get 9, which is also a positive. So this can't be 0. So when is this 0? When one of these pieces is 0. So that's why I wrote that. When is this 0? When x is negative 3. When is this 0? When x is equal to 3. So that is my solution. Now, depending on what we want to do, for example, maybe the problem said just a factor. We didn't want to solve the equation. Problem's just asking us to factor this polynomial. If that was the case, we would have been done when we got to here. But they probably wouldn't have set it to 0 if they asked us to factor. So by setting it to 0, they kind of want us to know, hey, when is this equal to 0? So that's why I went to this step. So we did a lot here. We used a formula. We emphasized that this formula is one that we should not forget, because it's going to come up a lot. We used it with something of x to the 4th, and another 4th power. And we dealt with a product of 3 terms right here. 2 binomials and this irreducible quadratic.